I'm going to keep staring. Hello, my name is Natalie Tarry. I am a maths and mindset tutor, have my own business based in Wrexham, which is called Natamatics Tuition Limited, often with the tagline, maths with a smile, because do you know what? I strongly believe that maths doesn't have to be something that you dread, you fear, and has this, you have this frown when you think about it. We can think about things with this smile, and the more we do that, easier it becomes, even if it is difficult. That's okay. So what I wanted to do in this video today is to go through an example of a question from WJEC intermediate level. And it's a perfect example of how mathematical thinking will really help you to access a question that might look a little bit abstract to start with, but actually, when you learn a particular way of thinking, suddenly it becomes a little bit easier. So just bear with me a second. I'm just going to share my screen now. Everything's set up, ready. Okay, so as I say, this is intermediate level with for WJEC. Intermediate level has the highest grade you can get is a grade B, and this is a good question to illustrate the whole mathematical thinking style that will really help you. Now, in maths, there are things that are basically just a skill. So if you know how to add, if I ask you a question 2 + 3, you will then know how to add. You'll know the answer is 5, whatever method it is you use. Questions like this are not necessarily one that you would necessarily have learned. You have to learn a reasoning, problem solving, mathematical thinking to help you to do this. Some people will say, well, it's obvious, you just do this and this, and that's okay. This isn't necessarily for you. However, if you are able to look at a question like this and just know it, it's well worth watching, just so that then you can learn the skills, so that if there was a question that you were a little bit, I don't really know where to start on this, these skills will help you. Okay, so let's go. Now, actually, as I'm recording this is on a Monday, the 6th of October in 2025. In half an hour's time, I'm going to be getting a phone call from BBC Radio 2. So this is kind of keeping me busy just before that phone call comes. So I just thought, you know what, I need to get these recorded because there's so much value in what I'm able to help people with. So let's get on with it. So before that phone call happens. So first question I would say to you is, look at your question and highlight any words that are mathematical. Okay, and by that I mean the kind of words that you will have come across in your maths lessons. Yes, there's lots of words in there with and is and all that such like, but what words are there? I'm trying to limit it to 5 if you can. It takes practice. What are the words in this question? I'll just give you a chance to think about that. I'm just grabbing my pen just while. So normally I would say just press pause, have a think about it. But obviously I was reaching for my pen, so just bear with me. Okay, so what have we got on here? We've got clearly a triangle, all right? And it says so in the question there. It also talks about an isosceles triangle, or isosceles, as I would often say. It's just a way to help remember how to spell it. Okay, what else have we got? Well, we've got a triangle with an A, B, and a C. We have some expressions, we have some letters there, which I know for many people will be like, no, thank you, and they'll go on to the next question. And then it says calculate, which is quite a generic question. However, it's well worth noting. Quite a generic word, I meant to say. Okay, so, right, I love this question purely because of the opportunity to demonstrate these particular skills. So, okay, what do we know about the words that we have highlighted, or what we can see in the diagram? That's my first mathematical thinking question. What do we know about it? Well, an isosceles triangle. Well, if I was practicing these skills as a revision exercise, what I would be doing is saying, I'm just going to have just a WhatsApp message just popped up. What I would be saying is go through the questions in your paper and mark everything you know about the things that you can see in a question. So for example, triangle, it's three-sided, it's a polygon, and I'm actually going to write these down in real time for you there. And then it'd be like, well, what is a polygon? It's a 2D shape. And this is just to general, I'm giving you lots of added bits in here as well. So it's a 2D shape with straight edges. Lovely. Okay. And I've done that quite roughly there. Okay, we've got isosceles triangle. Well, an isosceles triangle is one that has two sides same length. And I'm going to do this very much in shorthand. So two sides are the same length. So all we're doing really is we are doing a fact retrieval from our brains. And you know what? If we're doing this as an exercise for revision, what I would be doing is if I couldn't remember something, I'd be like, go on, go back and you look in your book, go and have a look in your book and you remind yourself what that is. Okay, so all this is at this point is factual. Okay, so two sides the same length. What else do we know about an isosceles triangle? Well, the two angles that meet the third side will be equal to. So, and I remember doing this with a student last week, and she says the two sides the same and the two bases. And I talk about the language that we use around maths. It's the angles that those two sides make with the base. And I say the base, the third side that isn't an equal length to the others. So two equal angles. Okay, wonderful. So again, just move that down a little bit. I know my writing isn't the neatest, but hey ho, I'm just trying to do this reasonably quickly before, obviously, I've got something I need to do. All right then, so let's have another bit of a recap. So isosceles triangle, so two sides same length. A triangle is a three-sided polygon, a three-sided shape with straight edges. There's nothing really else there, is there? Okay, so let's have a look at our diagram. So our diagram, we've got these two lines here. What do they mean? Well, what they do is they tie up the fact that it's an isosceles triangle. So if you didn't have that word isosceles there, it would tell you that those two sides are the same length. So therefore, mathematical thinking, what does that tell you about these two angles here? I'm just holding on to that in a second because obviously there's a doorbell going. I'm going to keep going. I'm not expecting a lesson. So it means that that angle there and that angle there will be equal based on what we wrote at the beginning. Two sides are the same length and the two angles that those sides make with the base or the other side are equal. Okay. It says find, calculate y. Okay, well, what are these things here? It doesn't mention them in the question, but they're on the diagram. So it's like, okay, well, they're angles. So I'm going to write down, okay, well, we've got angles mentioned or seen in this question. Angles, right. Mathematical thinking style. Next thing is, what links can we make between the words and the fact-finding thing that we've done in our question so far? So is there anything that we've learned that connects the things in the question? So, all right, well, we've got isosceles triangle. We've got angles. Well, triangle and angles. What have you learned in maths that links angles and triangles? What facts are there that you've learned? And this is really important. You have to learn your facts because unfortunately this mathematical thinking won't help you if you've not learned your facts. Okay, so those angles are the same, and I'm going to write this down here. So hang on a minute. So angles in a triangle add 280. Okay, so again, I'm just tying words together that are in the question to kind of help me think what's going to be useful to me. Okay, so angles in a triangle add to 180. Lovely jubbly. Right, what can we do now? Is there anything else, any other facts that we've got here? Well, the next thing would be, if you kind of get to a point where you're thinking, there's nothing else I can talk about with this question, the next thing would be, what can I do? What can I link these things I've written down here to the actual physical information in the question? So I've been given some detail here now, haven't I? I've been given these angles. Now, don't worry too much about the fact that these have got letters in them. They're an expression. Treat them as if they are a whole number or a number, because ultimately that represents the size of an angle, as does that one, as does Y. We just don't know numerically what it is, but that's okay. We make these letters our friend when we're having to do maths, okay? We just treat it as if it were a letter, a number, sorry. Okay, so it says there, angles in a triangle add to 180. So that plus that angle plus that angle adds to 180. How can I write that in mathematical language, I guess? Well, I'm going to take that first angle there. Oops, sorry. 4x minus 3. Then put my brackets around it. Plus, if I add it to this one here, and I add it to that one there, again, I'm not going to worry too much about what it is. I know they come to 180. Okay, so that's just taking the facts and relating it to what's in my question. Okay. Now, if you are intermediate level, means you will have to do simultaneous equations, bit of a hint. And if you saw something like this in another level of maths, apart from foundation in England, sorry, a foundation in Wales, if you've got two things that you don't know, so an X and a Y, you would need two equations to solve it. So kind of have that in the back of your mind, okay? Right then, so right, well, I've only got one equation here, so there must be another one somewhere possibly. Or is there another fact that I've not related to the information in this question? Right then, so remember an isosceles triangle. So go back over the preparation you've done at the beginning of the question. So two sides, same length, two angles are the same. The sides that are equal in length, they have two angles that are the same that they make with the third side there. So that means that angle must be the same as that one. Okay, so we've already kind of approached that, haven't we? So it means that that first angle there, 4x, which is for whatever x is, doesn't matter at the minute, but 4x minus 3 is equal to, sorry, plus, I'm looking at the plus above it, is equal to that angle there, which is whatever x is, add 48. Okay. What can I do with what is in front of me? That question is more than, or probably the one that I probably started doing and teaching students years ago. What can I do with what's in front of me? Because there isn't necessarily going to be a direct link from you seeing this question to knowing what methods you're going to have to use. You have to look at what you've got and then think, all right, what can I do with that? So I'm aware that this is probably could be a bit neater. So I'm just going to do this a bit neater now and without looking at the screen. Now, I know that I've only got one thing here I don't know, which is x. So if I were to rearrange this, so I could have x's on one side and numbers on the other, I could work out what x is equal to. So I'm going to do that. And all I'm going to say to you is at this point, I'm not going to go over to this in big detail. If solving equations will be something we could do at a different time. Okay, so I'm just going to move my visualizer up slightly. Autofocus. Oops, just aware that that's not really doing very well. It's because I've moved it. Hang on a minute. Let me just tweak. I can always edit this out later. Okay, that's how we'll do it. I'm still quite new to this whole visualizer thing at the moment. So if I move it in a different direction, don't worry. Do you know what? I'm learning too. Right then, so I'm not going to go into the ins and outs of solving equations. So for the whole purpose of this particular exercise, when you've got x's on both sides, subtract the lowest number from both sides. So you've got a 4x and you've got a single x. So you're going to subtract that x from both sides. So you end up with 3x minus 3, because we've not done anything with the number. Those two have moved, so you're left with 48. Okay, then, right, well, if I add that 3, if I cancel that minus 3 out, if I get rid of that, I do that by adding 3, because we always do the opposite to cancel something out. And you can do that all the way through your maths. So adding 3 to that gets rid of that. So you're left with 3x equals 48 plus 3 is 51. And then to get x on its own, we divide by 3. It's the opposite of multiplying, because 3x is 3 times x. 51 divided by 3, can work that out, is 17. Okay, wonderful. I'm very conscious of time before I get my phone call. I need to get a drink before I get on radio with Sarah Cox. Right then, so what can I do with this then? So go back to your question. And again, I could tell you exactly what the steps are to do this question, but that's not the point of this video. The point of this video is getting you to think about, or teaching you those skills. What could I do next when I'm not really sure? Okay, so, well, we know that that angle plus that angle plus that angle is 180. I know that that angle is the same as that. So again, go back over your the things that you've already written down. There's value in doing that at the beginning. But actually, well, what is the size of this angle? Well, I know that x is 17 now. So, and I know that that angle is the same as that one. So actually, that angle there is x, which is 17. So it's 17 plus 48. Now, do the maths, add that up, and that's 65 degrees. Okay, what does that mean? We can also work out now. Mathematical thinking skills, flag again, very popular question that I would get, you would ask. What can I do with this now? Well, I know that that's the same as that. So that angle there must be 65 degrees. Okay. What was the question asking us? It was asking us to calculate the value of y. What is y? Where is it? Well, it's here on this triangle. Remind ourselves of what the facts that we've kind of pulled out from our brain, just to remind ourselves. We know that they all add up to 180. Okay, so let's go back to what we've written down already. Slightly different colour. Let me just get a different colour pen. Oops, I'm picking a different colour pen and I'm picking a green one again. Let's go for orange. Okay, just bear with me a second. All right then, getting a bit nervous now. I'm going to give this phone call. So we have got that angle there is 65. So I'm using what I've already written down. Well, 65 plus 65 is 130. So all I'm going to do now is I'm just going to write this down here. Well, I've got y plus those other two angles, which comes to 130 degrees. And I know that adds to 180 degrees. Notice how, if you're watching this, play it back again. Notice how much stuff I've actually said. I know that. I know that. Don't worry too much about the route to the finish. You're constantly reminding yourself of I know that. So y plus 130 is 180. Well, if I want to work out what that is, I've got to get rid of that. How do I get rid of a plus 130? I take away 130. Okay, so that means y is equal to 50 degrees. 6 marks. Thank you very much, WJEC examiner. There you go. Now, I'm just going to recap just for two minutes now, very briefly. It's not about this 50. Now, obviously, yes, it's good to get to your answer because, you know, and if you've done it correctly and you've, you know, especially showing your method, just make sure you're ensuring against any avoidable errors you might make. But if you get to this, great, wonderful, you'll have got your 6 marks. It's not specifically asking you to show you're working out. So if you get that of 50, you should get the whole 6 marks. But you don't, you want to make sure you show you're working out. But the key thing here is method. It's that thinking style. You can apply, you think about the things I said out loud. What do I know? What does that mean I can work out? All of those things are quite generic and you can use those throughout your maths exam paper. Okay, so I'm just going to stop sharing now just so you've got me bigger. Hello. So watch it again. Make a note of those things. I used to call them Natalieisms, but now I call it it's their problem solving skills, their reasoning skills. They're that kind of, that's the extra bit that for some people it comes naturally. And that's what I would call the kind of the maths brain. Thinking mathematically, it didn't. For me, it happens most of the time. But, you know, that's the process I have to do. Sometimes I can see what the answer is, but it's not about that. It's about showing those methods, following logical thought process. And if you have to, write those questions down that I've just gone through. What can I see? What do I know about it? That factual kind of regurgitation. Okay. Apply that to another problem that maybe you weren't sure how to do. See how you get on. Okay, I'd love to hear how you found that. Keep watching. If you've got questions that you would like me to feature in this, send them on. All right, you take care. And if you like what I see, please like, subscribe and share, because the more people who learn these skills, the better, because more people will be happy, which makes the whole world a nicer, happy place. All right, you take care. Bye-bye. Right, drink. Right, is my phone charged up? It's not even charging up. Yo, my phone's